Alright, sixth graders, welcome to kind of the first video. What we're looking at today is the Pythagorean theorem. And this is also on page 584. And a lot of you have heard of this before. This is for right triangles. Okay, the right triangles. These ones both touching the right angle are what are called legs, and the one opposite the right angle is the hypotenuse for this. Okay, and the formula that we're going to be using today is a squared plus b squared is equal to c squared. And a and b are both the legs, and c is always the hypotenuse. And it doesn't matter which one a and b are, they can be flipped around. So using the Pythagorean theorem, we're going to look kind of at example 1 and 2 are pretty similar. I'm going to go through kind of the check understanding for 1b, and it's where they give you the leg is 12 meters, the hypotenuse is 15 meters. So again, if it helps you to kind of draw a triangle, you can also plug it into the formula. So I know one of the legs is 12 meters, the hypotenuse is 15 meters, and I don't know what x is. So I'm going to go ahead and plug it in. 12 squared plus, I don't know the other leg, x squared, is equal to 15 squared. And it turns into just a stupid line problem for this. So I'm going to solve. I know I have 144, and I'm left with 225 on this side. I'm going to subtract 144 from both sides. Okay. Go ahead, double check that math, see what we are left with for that. And we should get 81. Now to solve to get rid of this x squared, it's kind of an opposite operation. So, you know, on stupid line problems, to get rid of a positive 7, we'd subtract 7. The opposite of 7x, we would divide by 7. So the same thing is true for squared. To get rid of it, you can do a square root. And just like on the stupid line problems, what we do to one side, we have to do to the other. So it's kind of like the square and the square root cancels each other out. So again, 81, it is a perfect square. So we're left with 9, and our labels is meters because it is a side of a triangle. So you can go ahead and try some, like example 1 and 2 are similar, where they either give you both the legs or they give you a leg or a hypotenuse. What I'm going to look at next is kind of example 3. And I'm going to try the check 3 for this. So you kind of have to look at the picture that they give to you on the side, where they tell you the span and the rafter length and the rise, and you kind of have to read through the problem for that. But you can see in that blue picture they give the rise, it makes a right triangle for that. So for the check 3, what is the rise of a roof if the span is 22 feet and the rafter length is 14 feet? And round your answer to the nearest tenth of a foot for that. Okay, so if you look at the span, that's the whole way. We only need half of this span. And I know I'm using the Pythagorean theorem here. So we don't need the full 22 feet. We can see the half span is where it makes one of the legs of the hypotenuse. So I'm going to plug in 11 squared. Oops, it skipped down. Better erase that. Okay, it makes 11 squared. They also give us the rafter length, which we can see is the same as the other rafter length, which is the hypotenuse. So where we're going to plug in the rafter length is 14 feet. So we're going to plug it in for the hypotenuse. Okay. And we're looking for the rise of the roof. So if you look at the picture, you can see the rise of the roof is also a leg. So now I can just solve like before. I know 11 squared is 121. 14 squared You can double check that math. That comes out to 196. So I'm going to solve like before. I want to get rid of the 121, so I'm going to subtract it from both sides. I'm left with b squared. Do the math there for that, and you're left with 75. And again, to get rid of the square, I'm going to do the opposite operation. I'm going to take the square root. So again, try this in your calculator. Look for the square root button you hit first. Actually, depends on your calculator. Try that and see what you get for your answer. Sometimes you have to hit the second button for this. It comes out to 8.6602. It keeps going on for that. You can also figure out if that's an irrational or a rational number. The directions though say round to the nearest tenth, so I'm left with 8.7 and feet for that. And then the last example in this lesson for Pythagorean theorem is where they give you three sides of a triangle and you just have to tell us, would it form a right triangle? So you can kind of look at example 4. I'm going to check the 4B. I'm going to try the check for that. And they say 5 millimeters, 6 millimeters, and 10 millimeters, and explain to see if that would form a right triangle. So I'm going to just plug that in to the Pythagorean theorem. And I'm going to plug in the highest number as the hypotenuse, because that would be the only way it would work. So I'm left with 25 here, 36, and 100. Okay, go ahead and add these. I'm left with 61 and 100. So I can see, no, these are not equal to each other. No, these would not form, these would not be the lengths of the triangle. And explaining, I can simply say 61 is not equal to 100, showing that Pythagorean theorem. So make sure you try at least 2 problems from each of the examples. So you should have a total of 8 problems you've tried at home and solved and checked in the back of the book. And come with any questions if you get stuck for Monday. See you then. Thanks.